No. So this is kind of the measuring block. We should all be able to do this problem right now. Okay, and so that's what I'm checking with you. Now I want you guys to understand that generally we can write like a derivative sign in front of any function, and we know how to derive just about anything and everything that comes our way right now. That is not the case with an integral. We can find the antiderivative of this without a whole lot of work, but there are times that it becomes much, much more complicated. Now, why can't I just distribute this x through? It's taking the 8th power. So what I'm going to do is I'm going to kind of think about a reverse chain rule, okay? And you know, you can think of the substitution principle within antiderivatives to be really a reverse chain rule operation. What do you think I choose as u? 3x squared plus 5. And it's okay if you left yesterday just a little bit confused. That's all right. Some of the stuff, you know, it takes a few days. Wait till you see chapter 6. So du, and to you guys, these these antiderivative techniques, these integration techniques, again, you know, if you rate this on a scale 1 to 5, we're at about a 2 right now in terms of level of difficulty. We have much more complicated integration techniques that we will get to. Okay. So du is what? 6x dx. All right. So just look at that up there. You don't know how to find the antiderivative of that right now. So what we need to do is we need to try to account for some pieces in place. When you take du, all right, do I have a constant anywhere up here that I move out? No, so I'll just leave it. So good. Enos says I have the x right there. All right, I have the dx right there, so I can substitute those. I have the 3x squared plus the 5, but I don't have the 6. So I'll just divide by 6, correct? And I get 1 over 6 du is equal to x dx. Now can I make my substitution? All the pieces are accounted for. My new integral, I have the 1/6 out front. Instead of 3x squared plus 5 to the 8th, what do I have? U to the 8th. And instead of, what? The x dx, I replace with what? See, x dx is replaced with 1/6 du. So as long as I have this 1/6 out here, and as long as I have the du here, then I'm good to go. So again, you're just making sure that all the parts are accounted for. Now, can I take the antiderivative of that? I sure can. What's the antiderivative of u to the 8th? U to the 9th over 9 plus c, and I got to multiply that by 1/6. And you get u to the 9th over 54 plus c. Some people are like, well, do you have to write c over 6? No, it's a constant either way. It doesn't matter whether you divide it by 6 or pi or sine of square root of 2. No, that's not your final answer. What do you need to do? Plug it in. What is u? So I got 3x squared plus 4, that quantity to the 9th power. Oh, it's 5? Sorry. Over 54 plus c. That's the antiderivative. So if I took the derivative of that, what would I come up with? Yeah, the thing I have right here. Question. This 9, you would have to FOIL this out 9 times. You would have to do 3x squared plus 5. You would have to multiply that out 9 times. No, you don't have to do that. Okay, here's 2 problems for you to try now on your own. Again, I just want to establish a sense of you guys feel like you're ready to get into your book, okay? So here's the problem, because I want you to be able to go home over break and work on some of this stuff. All right, here is example 2. This is the most basic type of problem I can come up with. And some people will be able to do that just by looking at it. Here's another one. This one's just slightly more difficult. I'm going to let you set to work on that. Go ahead. I'll pause this. Give you some time. As you have questions, ask me. Okay. All right. I need to, let's see what we have here. Everybody's choosing the correct u value, correct? Do you have u is equal to 4x plus 3? Did you have that? So you have du is equal to 4dx. Yes? Do you have a 4 up here? No. So you need to divide the 4 off. And so you replace it with 1/4 times the integral of u to the 9th du. Take the antiderivative, you get u to the 10th over 10 times 1/4 plus c. And you multiply it, and you will end up with your u to the 10th, which is 4x plus 3 to the 10th over 40 plus c. Now, I saw just about everybody have that. Is that correct? So my question is, do you feel comfortable getting into your book and trying these type of problems for an assignment? Okay. Now, those kind. Okay. I understand. Now, Jacob asked a very good question. He said, what do we use this for? Do you remember? Okay. Now, do you remember what this thing does for us? Finds the area beneath a curve. So you guys got to remember, we were using very, very basic stuff earlier. The question is, what if I give you this, the natural log of x squared times e to the sine of x dx, and you want to find the integration from 1 to pi? Well, why would we want to? Because I'll tell you right now that I'll give it to you as plain and simple, and there's just so much depth here. They have volumes of books written on it, but you guys recognize this. That's what we refer to as the bell curve, right? And the bell curve is extremely important in statistics and normal distribution. I'm going to tell you guys right now that this has a very, very complicated formula. And a lot of the work that we do in life doesn't have to do with functions that look like this. They have to do with functions that look like that. And so finding the derivative of this isn't really all that bad. Finding the antiderivative of this is nearly impossible without further development of calculus. So again, we're scratching the surface. Eventually, Jacob, what we would like to do is we would like to take this type of shape and we would like to revolve it around an x-axis and find volume. Eventually, as I was sharing with Taylor Blake was here yesterday, eventually what we would like to do as well is we would like to stick another integral in front of it and attach a y and a dy on the end and have what we refer to as multivariable calculus. So he's taking Calc 2 right now. So he did Calc 1 right away and Calc 2 second. He said Calc 1 is a breeze after this class. He said Calc 2 is definitely very challenging. I saw the stuff he's doing, and it was challenging. I couldn't help him with some of it. He was doing some differential equations that I never took a class on. I said, if you want me to help you, I said, I got to go home tonight, and I got to learn the material. I said, I can learn it, but I haven't. I can't just spout off stuff to you right now. So, yeah, tough stuff. But that's where we're headed. Okay? Yes. Yep, you are all smarter than me. I would hope that every student I teach is smarter than me. That means I'm hopefully doing somewhat of a decent job. Okay. So, It seems like I have about 35 out of 36 of you that are smarter than me right now. One of you seems to still cling to this positive and negative infinity idea. Somehow we'll move past that, and then life will be good. So this one right here, what is u? So u is x to the third plus 1. What is du? Now, at this point, when you get to this type of a problem and you say, well, I don't want that negative 4 there, go ahead. Move the negative 4 out front. People, I'm going over this for your benefit, not for mine. I already know how to do these problems. So what you have right now is we got to divide by 3 so that you have just that du, 1/3 du is equal to x squared dx. Do I have an x squared dx? So when everybody wonders, how do I just get rid of that x squared? Again, that x squared and that dx goes away with the 1/3 du. So you have negative 4/3 times the integral of just then u to the 4th du. And then you could go from there, right? What's the final answer? And after a while, you look at it, you're like, hey, I could have probably just seen that from the beginning sometimes. So, okay, flip the notes I gave you yesterday, flip it over. We're going to do one more example problem. Then I'm going to have you go into your books and try some problems on your own. No. We're, you guys, we got to get to level 3 in terms of integration techniques when you get back. So we're going to try some harder stuff with this lesson later on. We're still at 2. Okay. Yep. No. And you guys, I think I heard Lucas ask a really good question about kind of the level of degree of difficulty problems we get to. We won't do the level 5 integration technique. We'll get to 3. That'll be it. I'm just telling you guys right now that we'll dabble in later in the year. We'll get to level 4 integration techniques a little bit. But you gotta learn more calculus before you can handle those type of problems. And some of you guys are satisfied with just saying, hey, I don't care if I don't know how to find the antiderivative of certain stuff. But some of you aren't. You're like, I want to be able to find the antiderivative of anything. And eventually you do learn that through calculus too. Yes. No, I'm just making it up. Okay, so we go to the last problem from yesterday. Right here, number 6. We have 4x plus 2. Should be a 4x plus 1. 4x plus 1. We have 4x plus, no, yes, 4x plus 2 is correct. Sorry. Yeah, that's absolutely correct. Absolutely correct. Okay. So we need to find the antiderivative of this. What do you think we select to be u? And then I say du is equal to what? Dx. Now, as you look at that type of a substitution, do I have a 2x plus 1 up there? Yes. Okay, you guys all see very important parts here. Let me show you something, though, okay? Remember at the beginning right away I wanted to look at this. I was going to change it to a 1 as I just didn't see the problem all the way through. But if we did change this to a 1, or let's say it was 3, then all of a sudden the problem would be significantly more difficult. You do have a nice relationship here where if I simply just multiply this side by 2, 2 du is equal to 4x plus 2 dx. And there, you guys, there's no process by which you say, oh, this is how every problem goes. You have to be able to recognize these type of relationships and work through it, okay? All right. So now I could go ahead and make my appropriate substitution. All right. So I have an integral. What should I put out front? 2. Does the 4x plus 2 go away? With what? The 2 du. So I've got the 2 du right there. I'll just put 1 on top over u to the third. Well, that's an easy problem to find an antiderivative of. You could just rewrite that as 2 times the integral of u to the negative third du. What's the antiderivative of u to the negative third? Two u to the negative 2 over negative 2, right? Yes, we are finding the antiderivative. I added 1 and I divided by my new result. So we cross off the 2's, and what we have is negative 1 over u squared plus c. What do I do now? Yeah, I just make my substitution now, so I have negative 1 over what goes in the bottom. Thank you. I can't see my worksheet. That's it. So again, substitution techniques. Shh, guys. So what's going to happen again is as I have this type of integral. Okay, so I'm going to have the square root of 2x minus 3. And I'm going to take that figure and I'm eventually going to take that graph and I'm going to revolve it around the x-axis and I'm going to find volume of a half of a football. And in order to do that type of a problem, okay, that's just area. We'll get to the volume piece later on. But you have to be able to find the antiderivative of that. In order to find that antiderivative, you have to use substitution. So to be able to do chapter 6, you've got to be able to do the stuff from chapter 5. So let's learn it well. You've got 25 minutes to work on an assignment. I want you to open up to page 365. Numbers 1 through 22. Now, the good news is that you don't have any homework again until when? Tuesday. All right? Now, I kind of forgot about the homework piece we had from the other day, so here's the deal. I want this homework and the homework I assigned to you, 1 through 38, I want those problems handed in Wednesday when you guys get back. So if you got questions on Tuesday, we can look at them. I don't mind giving a little bit of time on Tuesday to look over some of this, but then I want to get to harder problems. Question, Isabel. Put the 53 and 54 right on, well, right after the 1 through 38. Yes, that should be there as well. Hold on. Last thing. I just got done last night. Guys, listen up. Listen up. Boys, please don't talk. Last night I just got done finishing up my, basically just about all of my